Okay, now we will study how we can choose this curve. What is this curve? Before looking at the function, think about this. It starts from 0 and it always increases. It always increases and it is always below 1. It converges to 1 as this like horizontal axis goes to infinity. What is this? Think about any probability function, any probability distribution function satisfies this property. Always it starts from 0 and ends at 1 and it always increases. So probability, you may think any probability distribution function for this functional form, then of course the most common choice is the standard normal distribution. What probability would you use? Then always people think of normal distribution. Yes, we use that. And define phi, it's a Greek letter, phi z is the normal distribution function, which represents probability that a normal distribution is below this lowercase z. So this is a probability, and you may write probability of denial in this way. So not only linear function is taken by another function which is nonlinear, which make the probability prediction always lies between 0 and 1. So because of the function phi, which is nonlinear, your probability prediction has the correct range. That is the role of this guy. Then you may understand this in two ways. First, you have some kind of linear function, beta 0 plus beta 1x. So far, this is linear, that's step 1. And step 2, you take a nonlinear function, phi, to make the linear function into a probability. So the first step, the inside linear function is called z-value or z-index. More intuitively speaking, when you apply for mortgage, suppose that the banker grades your application. So it gives a score to your application. Say if your score is say 100 points, then you will be accepted 100%. And if your score is 50%, then you will be accepted 50%. And if your score is minus 10, then you will be accepted at a different probability. So in that way, so the inside captures some kind of score, which is purely imaginary. You never observe the score, but we just assume that there is a score, which is a linear function of x. And then once you get the score, then you are assigned a probability by this function. That is maybe I believe it is an easier way to understand. So for example, suppose that your score starts at -2. Just this is an example. Suppose that if your PI ratio is 0, then your score is -2. And for additional PI score, your PI ratio, your score will increase by 3. And then your score will be calculated this way. And then you get a score like say -0.8. Then given this score, your denial probability is determined by this normal distribution. So remember, we are using the standard normal distribution. So if your score is -0.8, probability below -0.8 is about 21.2%. So your denial probability is this much given your score. That is just how we are going to interpret the problem model. There is no reason, again, the score and the standard normal distribution is just an ad hoc explanation to make it work smoothly. But you never observe, and it doesn't mean the bank is actually working that way. We don't know how the bank decides on the mortgage application, but just like a supply demand functions, we are making a model that explains the banker's behavior, and it works nicely. So people use this. And so then we have all the things. It satisfies nice properties, like always increasing and between 0 and 1. And it is easy to use because the normal distribution is well known. So it is not easy to calculate the normal distribution probability by hand, but computers can do. Computers, any program, even Excel or any program has normal distribution probability built in. Or you may Google normal distribution table. So handling normal distribution is pretty easy. And interpretation wise, so we have an imaginary index, z-value. This is z-value index, and we can predict the z-value. But actually it has no real world interpretation. So it's just imaginary score, and then beta 1 has no real world interpretation. So the interpretation of beta 1 is now when x increases by 1 unit, your imaginary score increases by beta 1. It means nothing in the reality because there is no such score. You don't know how the bank grades your application. So score is purely imaginary object that we use only for theory. So that's another thing you have to be careful. Implementation on Stata. Of course, I will demonstrate Stata later at the end of this slide with homework, but just I'd like to show you it's pretty simple. In the place of regress, we used to use regress y on x, but now instead of regress we use probit. Probit dependent variable is denial, and pi ratio. So probit regress deny on pi ratio, comma option r. R is an abbreviation of robust standard error. So you may use robust, the same thing. So there are many abbreviations, which you don't need to. It will be convenient if you use the abbreviation, but it's not important. And it's simple. Implementation is simple, and the result is simple. Exactly the same format. So you know how to interpret this. Same p-value, same. Now it is not t statistic. It is called z statistic. But interpretation is exactly same because z and t both converge to the standard normal distribution. So if this is greater than plus minus 1.96, the coefficient is statistically significant. So interpretation is the same. Or 95% confidence interval. Using this, it's always positive, so it's statistically significant. Robust standard error and coefficient calculate the same way. Everything is the same. So here, these are exactly the same, and when you report, you may report it this way. But I want you to use the regression result table, not this equation reporting. I think table looks more formal, and that's more commonly used, so it is not recommended. So then let's see. Higher pi ratio increases. It is so positive. The coefficient positive. So higher pi ratio increases the denial chance of denial. It makes sense, right? So higher PI ratio means you are paying too much or your income is low. Same thing. So you are more likely to be denied. That makes sense. And standard errors are small relative to the coefficient. So the coefficient is about, say, 6 times greater than the standard error. So t-stat is like about 6. So which is good. And you may predict the probability in the same way. So if your PI ratio is 0.3, then plug in 0.3 in X and calculate the z value using the estimated coefficients. Then you get a z value of minus 1.3. Minus 1.3 has no real world meaning. It has no interpretation. It is just some number on the standard normal distribution. And find the standard normal distribution table to see the probability below minus 1.3, which is 0.097. So at this PI ratio, conditional on this PI ratio, the probability of denial is only 9.7%. So that's the result. That is the result, but minus 1.3 has no interpretation. Similarly, you may calculate the denial probability at 0.4 when PI ratio increases to 0.4, then your score increases to minus 1. And probability smaller than minus 1 from the standard normal distribution is about 15.9%. So when PI ratio increases from 0.3 to 0.4, the predicted denial probability increased from 9.7 to 15.9%. So this is how we interpret the results. And as I said, minus 1.3, the z value increase from minus 1.3 to minus 1 means nothing. It means nothing. So the score does not exist in the reality. So that means nothing. You may add additional variables as you did in the regression. Like if you have a second variable, you may add like this, or if you have more, let's say you can say plus beta 3x3 plus beta 4x4, you can go forever. What you are doing here is anyhow you get a score, get a z value by a linear function, and then plug in the z value into standard normal distribution. Then you will get a probability. That is the underlying mechanism of the probability model. So extension to multiple variables is straightforward. Interpretation is similar. Beta 1 is the effect of x1 on z value when x2 is held fixed. But what is the effect on z value? It has no interpretation. Z value has no real interpretation, so that could be a little bit troublesome in some cases. And implementation with multiple regressors is no difference. Just like remember, when you have a regression model, you used to write regress, deny, PI ratio, black, comma, robust. Same thing, replace regress with probit. So probit, deny on PI ratio, black, robust. So, and the result is also familiar. You have like variable by variable results. And black, the result for black is, so coefficient is 0.7 and standard error is 0.08. And t-stat is, I will call this t-stat, so there is no difference, virtually there is no difference. So the t-stat is 8.51. It's calculated exactly the same way. It's 0.708 divided by 0.083. So I will call this t-stat, and p-value is 0. Confidence interval is given by this. So also confidence interval is plus minus 1.96 times standard error. So it is the same thing, and there is no difference. Interpretation goes the same, and everything will be the same as before. Okay, I'm going to continue in the next video. I will stop here and we'll continue what we did in the next video. Okay, see you later.